Hey, Geometry, before I go on to the second part of 1.3, I want to correct one thing I did here. We're not, well, this little, I marked these little congruent angles with a little line. We tend to use that for the segments. I've seen it done this way, but it's actually not the way that we're going to focus on it. We'll just do like a single arc to show, or multiple arcs, and that'll actually show right here at the top of this page. So what this arc here is showing that this angle is congruent to that angle, which means that those angle measures would be the same. This with the 2 arcs is congruent to this one with 2 arcs, and this angle here with 3 arcs is congruent to that one with 3 arcs. So we can use that information to answer some of these questions. So angle CBJ, remember B in the middle is the vertex, so CBJ, this angle with 2 arcs is going to be congruent to this angle with 2 arcs. So we could call that a couple of different things, angle DHG or GHD. Angle FJH, angle FJH in the middle there with the 3 lines is congruent to this one right across from it there. And so that's also still got the J, but I want to go in this direction, so I would call those points A and B, where we assume that those points correspond to those intersections. So AJB or BJA. So AJB or BJA. All right, so then if we know that angle EFD, so that's this one up here, EFD, if we're told that that's 75, and assume they mean 75 degrees, and not everything's always drawn to scale, but that looks about like it might be 75 degrees. So we'll assume that's what was meant there. If that's 75 degrees, then what can we say about JAB? Well, JAB happens to be the angle that's congruent. It's got that 1 arc there, so JAB will also be 75 degrees. Since those are congruent angles, their measures are the same. And the measure of angle GHF is 130, we'll assume degrees, and so then when we talk about this angle JBC or CBJ, but they call it JBC, that angle is the same, is also 130 degrees. So we can answer those questions. All right, so a angle bisector, so you can kind of guess what this is. A segment bisector is cut in half by something. An angle bisector, the angle is cut in half. So the angle, a segment, ray, or line that divides an angle into two congruent angles and 2 equal halves in measure. So 2 congruent angles. So a picture of that, we want KE to be the angle bisector of angle K. So probably should have called this something a little different, but we'll call this angle K. If I'm going to bisect that, I'm going to try and split that into 2 equal measures angles so that this angle and this angle are the same measures so that those are congruent. And I'll throw an E on here. And really by doing that means we probably shouldn't have called that angle K. We probably should have a more specific name for that involving both of those sides of that angle. All right, so then a few more practice problems using angle bisectors and things. So AT, this is the angle bisector of MAH. So that tells us immediately that we know this angle is congruent to that angle, right? Since it's bisecting the MAH, cutting it in half. So measure of angle MAT, sorry, this should have been on here, is 60 degrees. So that should have just, I didn't figure that out. That just should have been on that problem to be able to figure this out. So so we can actually solve it for x. So if this is 60 degrees, and then measure of TAH is 4x plus 20. Well, because those angles are, and that really is in degrees as well, but because those angles are congruent, we know their measures are equal. So we can solve for x this way by setting up an algebraic equation, similar to what we did with the segments, where we set up that equation. We know 60 is equal to 4x plus 20. So we subtract 20 from both sides, do our algebra, cancels. So we have 4x is 40, divide by 4, and we get x is 10. So I've solved for x, and that was what the goal was there. Technically, the whole thing should have been degrees. So it's it's kind of like 10 degrees, but that you should also then have a 20 degrees on that, or a degrees on the whole thing. So depending on how we define that, we may or may not want to include that degree marking. Over here, we are not told that the angle bisector is there, but we're told that angle LOV, so this angle, is congruent to angle VOE. So basically they are bisecting again. It just didn't say it that way. Instead, it said that those two angles are congruent. So that means the measure of angle LOV should be equal to the measure of angle VOE. Once again, this wasn't given. What should have been given in this problem was 3x plus 12. So we know that those two measures are equal to each other. So we can actually set up an equation and solve for x. So 7x minus 14 is equal to 3x plus 12. And get solvent. I'm going to bring x's to one side. I'm going to subtract 3x. That's a smaller one. Keep things positive. Cancels that out. And at the same time, I'll go ahead and move this. I'm going to add 14 to both sides. And that'll cancel that out. So on my left side, I'll have 7 plus negative 3. 4 x's is equal to, and then 12 plus 14 gets me up to 26. So if we divide by 4, we get, and that cancels, we get x is 26 over 4, which is 6.5, 6.5. So that is the value of x. So sometimes a question might ask for that. Another thing a question might ask for is, what is the measure of angle LOV? So what we can do is we can take what x is and plug it back in. So it would be 7 times 6.5 minus 14. And that would actually give us the measure of angle LOV. And so in this case, if you do 7 times 6.5, that's 7 times 6.5, we get 45.5. 45.5 minus 14. And then if we subtract that up, we're going to get 31.5. And so the measure of angle LOV is equal to 31.5, and that's probably, measuring in degrees, and maybe we should have been including that throughout, but as long as we get it in there in that answer, that'll be fine. So that is measuring angles and getting going with angles.